Now let us solve this integration problem. First, integration with respect to y. So we must be sure that the limits are in terms of, not in y terms. They are either x or z or combination of x and z. So already the limits are in terms of x and z. So first we're doing the integration of this part here with respect to y. While doing integration with respect to y, x and z are treated as constant. That implies integration of 2x with respect to y is equals to 2xy, and integration of 4z with respect to y equals to 4zy, because the 4z is treated as constant when we are doing integration with respect to y. After doing integration, the limits, here is upper limit x plus z, lower limit x minus z, putting the limits here and simplifying. After simplification, we get here 4xz 3 by 2, 4xz and 4z multiplied by 2z. On simplification, we get this much. So we got 4xz and 6xz and 12z square. Now here the next integration with respect to x, and limits are in terms of constant, no problem. So 0 to 2, and while doing integration with respect to x, z and y, these two are treated as a constant when we are doing integration with respect to x. So integration of 4xz with respect to x. So 4z is treated as a constant. Integration of x dx, this is equals to 4z, and integration of x is x square divided by 2. 2 and 2 get cancelled. So we get 2z x square. Similarly, the other terms and limits are 0 to 2. And after that, putting the limit 0 to 2, so we get 8z, 12z and 24z square, which is equivalent to 20z plus 24z square. Now integration with respect to z. So integration of 20z with respect to z is equals to 20z square divided by 2, and integration of 24z square, that is equals to 24 integration of z square with respect to z. That is nothing but the integration of z square, nothing but z cube divided by 3. So the limits are minus 1 to 1. And after doing integration with respect to z, and limits are minus 1 to 1, putting them and simplifying, we get 16. So this is solution.